All right, welcome back to Calc 2. So we're going to finish our double integral section here and see where we go. Okay, so let me share the screen so we can get to work. All right, so what we're going to do here is we're going to take a look at this problem. So this is a little tricky. 0 to ln 2, we have e to the y to 2 of 8 over ln x dx dy. Okay, so when I'm looking at this, like I don't want to integrate 1 over ln x or ln x to the -1. It's going to involve an integration by parts at best. Okay, it might involve other techniques, but I don't want to do that. That looks terrible, and that's a little frightening. But in this case, we can change the order of integration. By the way, if you're doing this problem, you're like, I kind of got it and I kind of didn't. I'm not going to quiz you on this problem. Okay, this is a little bit too much. For a homework problem, it's fine. So you can get a taste of what you missed out of taking Calc 3. But this would not be a good quiz question. Okay, there's too many things that can go wrong and too many places where you can go wrong with it. So I would not want to quiz you on this. So what we have to do is we have to graph the region. Okay, we have to graph this region. So x is going right between 0 and ln 2, sort of. Okay, no, x is going between e to the y, x and 2. Y is going between 0 and ln 2. Okay, so first off, how do you graph x equals e to the y? I mean, you could kind of think about it like here's x and here's y, and look at it tilted. Okay, so it's going to be kind of something like that. But because we're doing an exponential curve but sideways, but you could also think about it as ln x equals y. We're taking natural log of both sides, and this might be a little bit easier to get your hands on. Okay, so x is going from ln here to 2, right? Where's the line x equals 2? We'll say there. Okay, so I just want you to think about like this area in here. Okay, we went from let's look as far as x goes. The bottom part was this curve here, and then the top part was this curve here. So we're looking at it from this direction. Okay, from y, okay, y is going from 0 up to natural log of 2. Okay, so if we type in e to the ln 2, type that in your calculators, you get 2. Okay, so right here, okay, we've got our values here. Okay, so rather than look at it from x and then y, what we're going to do is we're going to say, well, how about we say something clever like x is going to go from 1, right? We're going to say y equals from 0, right? From 0 up to 0 y to ln x, because that's what this is. Okay, so we're going to go from 0 up to ln x, and x is going to go from 1 here, this is 1, to 2. So this is what you have to do in order to swap the integrals, is you have to deal with the fact that one variable is in terms of another one, and that's how we have to go through and do that. Okay, this gets even more pleasant. Okay, but so if the goal here, what you're going to do is you're going to graph the region, and you're just going to kind of look at like, well, how do we express one variable in terms of the other? So if we give y's here, right, this from 0 to ln x, okay, is in a y direction, 0 to ln x, but my x direction was just going from 1 to 2. Okay, so for the y part, right, we're going from 0 to ln x for the x part, we're going from 1 to 2, right? And my integrand was 8 over ln x, and then we have dy dx. Since this doesn't have any y's in it, we could safely integrate with y first, see what happens, and then deal with our x's. Okay, and hope for the best that this comes out better. Okay, there's a lot of false starts in doing these problems, because sometimes it's like, well, let's try it this way. Well, that didn't work. Like, well, let's try this technique. That didn't work. Try change the variables. That kind of worked. So you'll just keep going until you kind of get it. But I would not be interested in quizzing you on a problem like this. I think for Calc 2 elements of, this is kind of a bit much to ask you guys to do on a quiz. To ask you on homework, we can explain it, but to do on a quiz, I would not be comfortable. I would not sleep well at night. Okay, so 1 to 2, just dealing with this, right? This is just 8 over ln x, and then integrating y is y, and we're going to go from 0 to ln x. Okay, and then we have a dx. Okay, that pairs with the 1 to 2 dx. Okay, so we're going to have an 8 over ln x, okay, integral from 1 to 2. And then for y's, right, we're just going to plug this in. We're going to say ln x minus 0 dx. Well, the ln, hey, wouldn't you, this must have come out of a textbook somewhere, right? Because we have 8 over ln x times ln x from 1 to 2. These guys cancel, so we just have to integrate 8 from 1 to 2. So we just get 8x, 1 to 2. And we just get 16 minus 8, 8, and you're done. Okay. Easier said than done. Okay, honestly. So if you were having trouble with this kind of a problem, you are not alone. Okay, engineering calculus students, they have a tough time with this one. Okay. Calc 3 people, because that's when they get to take it, they have a tough time with it. This is not a trivial problem. Okay, so I just want you to be aware of that and say, okay, we're going to do what we can, but there we are. Okay, find the average height of the paraboloid. This is another one that this isn't as bad of a problem, but I would certainly provide you this information. Average height. Remember, average value, it's 1 over the area times. Give me a moment. So, okay, so it's 1 over area times the integral. Okay, so I would certainly provide this to you because this is not information you should just be carrying around in your head. Okay, so not a bad problem, but I would have to give you this. Okay, so they want to know the average height, okay, is of this thing. So we're going to say z equals x squared plus y squared over 0 to x to 4. So at least we're back in the iterated integrals, so we can swap the order without having to deal with limits or functions, because when they're square like this, when it's between two constants, you're allowed to swap. Okay, it's called iterated integrals because it doesn't matter how we calculate the area of a square. Length versus height, or length versus width, doesn't matter which one you get first. Okay, so here we go. We have z is equal to x squared plus y squared. Okay, and we're going to be dealing with this. So here we go. We have integral from 0 to 4. 0 to 4. Who do you want to do first? Because it's not times. I can't float anybody through it. Okay, so let's go with dy and then dx. Okay, so let's integrate with respect to y. So we're going to have x squared times y plus y cubed over 3, right? And we're going to go from 0 to 4 with respect to y. Okay, we still have to integrate with respect to x, okay, and dx. So let's go ahead and evaluate for y equals 4. Okay, so we're going to have 4y squared plus 4/3, right? I'm sorry, not 4/3. We're going to have 4 cubes, plugging in y here, divided by 3. Okay, there was no x's. Okay, and then minus, if I plug 0 in, we're just going to get zeros, right? Okay, I hope we can take a little shortcut like that. Okay, and now we have to integrate with respect to x. Okay, 4 cubed is 64, so it's 64 cubed, plus we have a 4x squared, integration with respect to x dx. Okay, so integrating 4x squared. Okay, that's going to be 4x cubed over 3 plus 64 thirds times x, because it's constant and we raise the power up by 1 when we integrate. We're going from 0 to 4. Okay. Okay, so we should be okay there. Okay, so we have 4, and then this is going to be 4 cubed over 3 plus 64 times 4 over 3. So that's going to minus, and if I plug in for the zeros, we get 0. Okay. So let's see here. 64, that's twice. So 64 times 2 times 2. We do our little interims here. That's 168 or 128 times 2, and then that's going to be, it's going to be 256. Okay. So this is going to be 256 over 3, 64 times 3, plus 256 over 3. Okay. Add these together. Okay, and we're going to get what? We're going to get 512. Okay, 512 over 3. But not answer yet, because we had to say 1 over the area, right? And how big, right? We have a 4 by 4 area here, don't we? So this area is 1 over, it's area 16. So 1 over 16 times 512 over 3. So this is 1/2 times 1/2 times 1/2 times 1/2. 512 over 3. So half of this is 256. So that's this one. Half of that again is 128. Half of that again is 64. And half of that again is 32. Okay, so 32 thirds. We'll check to see if I did my arithmetic right. Okay. So what is that? It's 32 thirds. Right, we did all our halves correctly. If you plugged it into the calculator, I have no objection. Okay, it's fine. Okay, so again, not a bad problem. I would certainly give you the average value is the 1 over area times that double integral. Okay, so don't worry about trying to memorize that formula. Okay. Manufacturer of a fruit drink has decided to try innovating packaging in order to revitalize sagging sales. Delightful. The fruit juice drink is to be packaged containers in the shape of a tetrahedron. So the people stocking that are delighted. Shown in the figure. Okay, so we've got like a edge of a plane here. And they want to know what's the volume of this thing. All right. So, good problem. So, to figure this out, we can do a couple of different things. We have the plane. Okay, we have 3x plus 5y plus z minus 15 equals 0. I want to do a volume. So if I have an f of x, y, z like equals w, and I want to figure something out for this, and I just want to integrate it that way, that's fine. But we don't have w equals. We have this equals 0. So it's going to be a little different. So what I really want to do is say z equals, and now we're going to say 15 because we'll put 15 on the other side, minus 3x minus 5y. Okay. I would like to do it this way. No, I don't want to do it this way because I've got the 15 here sitting here. Okay, so rather than lead you astray and then have to redo this, I'm going to pause you for a moment so I can make sure that we're doing this in the right direction. All right. So yeah, that's what I want to do. However, we're going to look at this graph for a second. Okay. So I look at the bottom here. This is not a square. This is a triangle. So we can't just assume it's going to go from 0 to one thing, 0 to the other thing, because that would give us the whole square. And we don't want that. We need to figure out the portion, the volume just for this triangular area here. Okay. And anytime you have something other than a square, we got to draw it. Okay. So what I'm going to do is we're going to go ahead and we're going to draw. So z is going to be equal to 0 because I'm just working on the xy plane here. So we'll set z equal to 0 for a moment. Okay, so we'll say this is 3x plus 5y is equal to 15. Okay, when z is equal to 0, 3x plus 5y equals 15. We'll just put these guys on the other side. And we're going to solve for y because we're going to make like a y equals mx plus b kind of a thing. So we've got 5y is equal to negative 3x plus 15. And then divide everybody by 5. So we have y equals negative 3/5 x plus 3. Okay, 15 divided by that. So 1, 2, 3. Okay, and then that's when x equals 0. When y equals 0, right? Where's our other intercept here? When y equals 0, we get negative 3/5 x plus 3 equals 0. Negative 3/5 x equals negative 3. Multiplied by 5/3. So we have x is equal to, it's a negative. Okay, so x equals 5. Okay, so 1, 2, 3, 4, 5. I should use method of intercepts. It would have been more clever. Okay, so we have that as our bottom. Okay, so this is the base of our little juice pack here. Okay. So what we're going to have to do is we're going to go for x is going to, or x is going to go from 0 to this value here, but y is going to go from 0 to this stop, okay, this line here. So y is going to go from 0, so should use it that way. Y is going to go from 0 to negative 3/5 x plus 3, okay. So that's y. Okay, so y goes from 0 at the bottom here. Okay. And then to the top, it bumps up to this roof type thing here, which is this guy here. My x, this is just happy going between 0 and 5. Okay. So we set our integral up. Okay. We're going to integrate with y first because we've got x's there. Now, this is going to go from 0 to the line negative 3/5 x plus 3. And we're going to go back up to our original thing here. This is 15 minus 3x minus 5y. Okay, just like we had up here. Okay, and x is going from 0 to 5. So even though you might be tempted, like we could change the integral sign, the limits, but we're not going to. Okay, I mean, it's a line, it's not going to be that bad, but most of us think in x is going to y's rather than y is going to x's. Okay, and this is not too bad of a problem. So if we just integrate this, this is 15y minus 3xy minus 5 over 2 y squared. What is our limits on y? Y is going from 0 to x. Y equals negative 3/5 x plus 3. Okay. Okay, and we still have x going from 0 to 5. So there we go. So not the nicest arithmetic problem we have to deal with, but it is doable. It's not that bad. Okay. So 0 to 5, we have 15 3/5 x plus 3 minus 3x negative 3/5 x plus 3 minus 5/2. We have negative 3/5 x plus 3 squared dx. All right. I think I'm going to stop it here because now we just have a function with x's in it. So it's a couple of lines of algebra. Okay. But I think our video has probably gone on long enough for us to do something here. But this is how you set this one up. And we're just going to integrate with x between 0 and 5, and then hope the arithmetic is right and get our volume. Okay. So I think you guys can take it from here. Right. But the important thing is you got to graph this thing first and get your y to be, it's not a square, it's a triangle. So we have to deal with that. That's the important lesson on this one. Again, this one would be, I would feel more comfortable about giving you something like this on an exam or on a quiz, but I still wouldn't feel really good about it. Okay, so I don't like to give you guys, weird on homework. Yeah, it's fine, suffer. But if you have a quiz, I prefer to do the integrals that are a little bit more straightforward than this. Okay, this would be great for engineering calc people, but I would feel a little bit bad about this. Okay, so go through, finish this off, do the arithmetic, get a volume. That's how you set it up. Okay, so we're going to stop there, and I will see you for chapter 10.